Hi, mathletes. Welcome to Thursday's lesson of week 7. We are going to take a look at the other special right triangle case today. It's called the 30, 60, 90 case, and it's called that after the angles in this right triangle. So you've got a 30 degree, 60 degree, and 90 degree angle in the triangle. So we'll do a bunch of practice problems, and then I will upload some practice worksheets for you to complete with the answer keys so that you can check and make sure that you're doing the problems correctly. This week, you need a lot of practice with this topic. And the practice is pretty quick, like there's Kahoots and quizzes that you can also play to practice and get the knowledge down, but you really want to make sure that you're completing that practice. If you have any questions, please send me an email. All right, so here we go. So again, a special right triangle, what makes it special? It's called a special right triangle because you only need to know one side length and you can find all three side lengths. So that's what makes it special. This special right triangle came about if you think about in an equilateral triangle. So a triangle where three sides are congruent and three angles are all each congruent to one another. So they're all 60 degrees. If you were to draw the altitude, so from one vertex perpendicular to that opposite side in. If this equilateral triangle, if we said that each side length was 2, so this would be 2, this is 2, this is 2. This segment here is half of that. So half of 2 is where the 1 comes from. And then this is a right triangle. So if you use your Pythagorean theorem and you did 1 squared plus x squared equals 2 squared, if you solve this with the Pythagorean theorem, you would get that this side length is the square root of 3. And so remember when we looked at 45, 90 degree triangles, the ratios were 1, 1, square root of 2? Well, for this special right triangle, my ratios are 1, square root of 3, and then 2. So square root of 3, if you were to enter that into a calculator, this is about 1.7 approximately. So again, the shortest side is across from the smallest angle, and then the longest side is always across from the biggest angle. So always keep that in mind. Let's take a dive into the parts of this 30, 60, 90 triangle. The side lengths we'll refer to them as the short leg, the long leg, and the hypotenuse. So short leg, long leg, hypotenuse. The short leg is always across from the 30-degree angle. Always, always, always. The hypotenuse is always, no matter what kind of right triangle it is, whether it's special or not special, the hypotenuse is always across from that 90-degree angle. And so the longer leg is going to be that middle side length across from the 60-degree angle. Again, the shortest side is across from the smallest angle always, and the longest side is always going to be across from the largest angle. Now, here is my formula up here. Your goal is, if you are not given the short leg, you want to find the short leg. That should be your goal in all of these problems. Get the short leg, because the short leg is x, so you want to find x. Well, whatever the short leg is, the hypotenuse is 2 times that. In other words, it's just double it. If the short leg was 3, the hypotenuse would be 2 times 3, 6. If the short leg was 10, then the hypotenuse would be double that. So 2 times 10 would be 20. So the short leg and the hypotenuse, they go together really nicely. So if you know one, it's easy to find the other. Now, if you were given the hypotenuse and you want to find the short leg, the hypotenuse, say it was 8. So if 2x equals 8, and you want to find the short leg, you want to find x, you would divide by 2, and so the short leg would be 4. So you're either doubling or taking half when you're going from the short leg to the hypotenuse or vice versa. So if you want to go from the short leg to the hypotenuse, you're multiplying by 2. You are doubling. If you are going from the hypotenuse to the short leg, you are dividing by 2. You're taking half. Now, from the short leg to the long leg, you are multiplying the short leg by the square root of 3. If the short leg was 7, the long leg is 7 root 3. If the short leg was 9, the long leg is 9 root 3. And again, when you're working backwards, so if you were going from the long leg and you wanted to find the short leg, you would be dividing by root 3. So we're going to cover all these cases. So buckle your seatbelt. Let's do a bunch of practice. All right. The first thing that I want to emphasize again is find that short leg. If you are given the short leg, jackpot. If you weren't, you just got to find it. That should be your first step. Find the short leg. Find that side across from that 30-degree angle. So here's a chart. So I set up again, and organizing it with the chart is always a good recommendation. And I've got 30, 60, 90, and I write my formula. X times the square root of 3, 2x. So this is my relationship. If the short leg was 5, the long leg is 5 times the square root of 3, and the hypotenuse is double the short leg. So 5 times 2 is 10. If the short leg was 24, the long leg would be 24 times the square root of 3, and the hypotenuse is double the short leg. So it'd be 48. If the short leg was 7, the long leg would be 7 times the square root of 3, and the hypotenuse is double the short leg. So 7 times 2, it would be 14. Do you see the patterns? So once you practice it, you pick it up very quickly. Now, another assumption that people make is they think that, oh, the long leg, because the rule has a square root of 3, my answers must always have a square root of 3. And that is false. So that's a very common question that kids usually have when we're doing this in school. For this last one, let's showcase that. If the short leg was the square root of 5, to find the long leg, I take the short leg and I multiply by the square root of 3. Well, root 5 times root 3, I can use my product property, write it with one radical, and 5 times 3 is the square root of 15. The hypotenuse is doubling the short leg. So if I multiply this by 2, notice how the 2 stays outside, because when you multiply a number by a radical, they don't mix. They only will mix if they're both radicals, like we had here. So you would just write it 2 times the square root of 5, just like you see here. All right, number 1. So a 30, 60, 90 triangle. On Tuesday, we talked about fill in those missing angles, and I definitely recommend that even more with the 30, 60, 90 case. So fill in any angles that you were missing. So I filled in the 60-degree angle. These are special right triangles because you only need to know one side length, and you can find all 3 side lengths. So you've got to figure out what side were you given, the short leg, the long leg, or the hypotenuse. So look at where the number is and look at what it's across from. It's across from the 30-degree angle. Well, that means it's the short leg. So I fill it in right in my chart. Now, this is the jackpot. If you're given the short leg, it's going to be so smooth to find all the other sides, because the short leg is what X. It's what all the other side lengths are built off of. The long leg is whatever that short leg was times the square root of 3. So it's just 5 root 3. The hypotenuse is double the short leg. So if I double 5, I get 10. So here are my missing side lengths. So the long leg, this would be 5 root 3, and my hypotenuse would be 10. On number 2, the first thing I ask is what side length was I given? It's a 30, 60, 90 case, so I know that this is my recipe that I'm going to be using. So I was given the side across from the 90-degree angle. That is the hypotenuse. So see how I made it a little bit bold? I fill it right in. I was given the hypotenuse, and I want to find the other side length. So get the short leg. If you weren't given the short leg, find it. So to go from the hypotenuse to the short leg, I have to divide by 2. So half of 24 is 12. And once you have that short leg, it is so smooth. I've got to find that last side of the triangle, which is the long leg. And I find it by taking whatever the short leg was, which was 12, and multiply by the square root of 3. So my side lengths, my short leg is 12, the long leg is 12 root 3, and the hypotenuse was 24. All right, let's take a look at 2 more. Number 3, it's a special right triangle. What case is it? It's a 30, 60, 90. So a 30, 60, 90, there's 3 possible side lengths: short leg, long leg, or hypotenuse. So I look at where the number was, and what side length, and what angle was it across from? It was across from the 60-degree angle. So that's the long leg. So I fill it in, copy and paste that side length right there. I want to find that short leg. If you were not given the short leg, that's what you find first. So when you're working backwards to go from the long leg to the short leg, you are dividing by the square root of 3. So I take this side length and divide by the square root of 3. Again, I mentioned on Tuesday that it is okay in this course, this level, to leave radicals in your denominator. So you can leave your answer like this. However, if you know that you want to take pre-calculus senior year or continue on, then that might be a skill that you just keep note that you'd want to make sure that you look over. Once you have the short leg, your hypotenuse is just double this. So just multiply it by 2. So remember, when you multiply fractions, you might want to make this first number a fraction by putting it over 1, multiply the tops, multiply the bottoms, and you can leave it just like this. On number 4, it is a 30, 60, 90 special right triangle. You were given the side length across from the 60-degree angle. That's the long leg. So I fill it right in. Get the short leg. That is my goal. To go from the long leg to the short leg, you are dividing by the square root of 3. So I take the long leg, I scoop it up, and I divide it by the square root of 3. And look, anything divided by itself cancels out to be 1. And 5 times 1, that short leg, is going to have a length of 5 units. Now, once you have the short leg, you can go cruise right through. The hypotenuse is always double the short leg. So if I double 5, I get 10. So my side lengths, I've got the short leg is 5, the long leg is 5 root 3, and the hypotenuse is 10. On number 5, it is a 30, 60, 90 special right triangle. If you want, you could fill in the right angle there. So you were given the side length across from the 30-degree angle. Awesome. So I fill that in under my short leg column. Now, the long leg is whatever that short leg was. I don't care that it has a radical. That is okay. Do not be afraid of it. Take the short leg and multiply by the square root of 3. When you multiply radicals together, you can condense them. Multiply 5 times 3, put it in its own radical. There you go. The hypotenuse is double the short leg. So scoop up the short leg and multiply it by 2. Now, non-radicals you can multiply together. 2 times 2 gives me that 4, and then the radical 5 stays as radical 5. So my final answer is 4 root 5. So to recap, radicals you can condense by multiplying the numbers that are in each of those radicals, and then non-radicals you can condense by multiplying. But you cannot mix a non-radical and a radical. Those numbers are going to stay separate. All right, the last one we'll do, number 6. The side length of an equilateral triangle is 8 centimeters. Equilateral is one of the vocabulary words that you've seen for probably a couple of years now. A triangle with 3 congruent sides. Draw a picture. So this picture, they did not have to give you this picture. They could have just given you like the 2 sentences here. So draw the picture to help. Find the length of the altitude. So again, another vocab word. Altitude is the segment from the vertex perpendicular to the opposite side. So it drops right down and forms a right angle with that opposite side. Well, if this whole side was 8, then this is half of it. So this would be 4. And so for this, it's a 30, 60, 90 special right triangle. You knew the short leg is 4, and you know that the hypotenuse is 8. And so the long leg is just going to be whatever the short leg was, which was 4, times the square root of 3. So the length of the altitude is going to be 4 root 3. And again, on these, like, it did not say to round, but if it did say to round, then you would get your calculator. But if you type this into your calculator, it's about 6.9. So it makes sense for about 6.98. The shortest side is across from the smallest angle, and the longest side is always across from the biggest angle. The last piece is find the area of the triangle. So again, something that all these pieces we've been studying all year. Area of a triangle, your formula, half the base times the height. The base and the height are those side lengths that meet at a right angle. We know the base is 8. We just found the height of the triangle. Remember, height is the altitude here. And so I'm multiplying. Half of 8 is 4. 4 times 4 is 16. And I've got 16 root 3. If they did ask us to round, which they didn't specify, but if they did, then you would go to your calculator and enter it in. So if you enter this into your calculator, it's about 27.7 centimeters squared. All right. So again, I'm uploading a bunch of practice this week. This is a big topic. Next week, we're going to start trig, which do not be scared of trig. It usually, trigonometry is usually people's favorite unit of the year, and that will be our last unit. So you might hear the word trig and be a little bit nervous. Don't be nervous. It usually is people's favorite topic. So I'm kind of excited that we're going to end the year with that. Email me with any questions. Have a great week, guys. Have a great Memorial Day. Bye.